Section 5 has a lot of factoring with polynomials, which you should have seen pretty extensively in Algebra 2, so a lot of this should feel like review. The way that I approach factoring is with what I call diamond method, and you might come across a few methods or ideas in this section, and I'll just try to make sure everything's organized. So this is supposed to help when you're factoring, but it's only under certain circumstances. For the most part, I use this when I'm factoring a trinomial. So that's implying that there are 3 terms in the expression. Think of it like a tricycle. Trinomial has 3 terms. So diamond method, we'll see that in the first example. We'll also see factoring by grouping, which only happens when we have 4 terms. So if we have 4 terms in a polynomial, chances are we'll be using factoring by grouping, so we'll see that. Difference of squares is when we have 2 terms, but one term is being squared, usually x squared, and there's another term that was squared. Sometimes this number is 16 or 81, some number that's a perfect square. Perfect square trinomials, we'll see those too. Sum or difference of 2 cubes, which kind of ties into example 4. General strategy for factoring polynomials. This is most likely going to be diamond method, unless I say otherwise. Factoring algebraic expressions containing a fraction. I don't think we see too much with negative exponents in this. So going into what, in my eyes, is a pretty basic trinomial to factor. So again, the whole idea with factoring is that we're trying to rewrite and go from some trinomial to 2 binomials that, when multiplied together, get us back to the original trinomial. And this can be checked. So what's cool about this section is that you can check your work using box method. So let's make a note on that. You can check your work either by foiling or box method. And so we are going to be looking at x squared minus 13x minus 14. Diamond method is going to be used here because this is a trinomial. And so what diamond method is just a way for us to think out how this is going to be factored before we actually say this is the final answer, we're done. So to collect our thoughts, in this bottom portion here, this is where our product goes. So this is the very last number that we have. So in this case, the very last number we have here is negative 14. Put that there. In the middle, this is going to be our sum. So the number that the factors of negative 14 have to add up to, and that's always the middle term. So I'll try to color coordinate here. So this negative 13, it's going towards the top. And so the ideas that we're trying to think out here, we're looking for factors of 14, negative 14, that add up to negative 13. So these are the main ideas that we want to think out whenever we're using diamond method. So we're thinking factors of negative 14. Well, we know that we have 1 and 14. We know that we have 2 and 7. And we're aiming for a sum of negative 13. Well, looking at this, I know that my product's negative, and the only way it can have a negative product is if one of these terms is negative. So we know that one of these terms has to be negative, the other term has to be positive. Well, if we think this out, 2 and 7 don't really get us close. If you could plug those in, check them out. I mean, you could think negative 2 plus 7, that definitely doesn't equal negative 13. Negative 7 plus 2, that doesn't equal negative 13. So this one's out. We don't even want to bother with it. I said bother. Who says bother? We don't want to bother with that because it obviously doesn't work. So 1 and 14 is going to have to work. If we think this out, we're trying to go down to negative 13. If we were at negative 14, that's pretty close. So let's add negative 14 and positive 1. And we can double check our work real quick. So 1 times negative 14 definitely gets us negative 14. That's for certain. If we have 1 and we deduct negative 14, that gets us negative 13. So that's for sure. So how we do this is that we want the first 2 terms of these 2 binomials to get x squared. The only way that happens is if we have x multiplying with x. Then from there, the 2 terms that we just came across, that we just worked on finding, positive 1 and negative 14, those are going to go in here. So we see positive 1, negative 14. And let's check our work just so that we know we can do it. It might seem like an extra step to check your work. When you're really good at these, you can just give a visual check, but for now, we'll check it. So we know we have x plus 1 multiplying with x minus 14. If we take all of these products, we have x squared, x, negative 14x, negative 14, negative 14x, and adding on x gets us that negative 13x, so our check is good. Because we can get back to that original trinomial if we use box method or foiling. So this is the check, but the main final answer that we want to keep is this. So we got that. Moving to the next part, we know that we're going to be factoring by grouping because we have 4 terms. So what grouping means is that we have 4 terms for sure. Hopefully we can all agree on that and see them. 32xy squared minus 50x minus 48y squared plus 75. So how this works is that we want to kind of just focus on the first 2 terms that are in here. So you might recall from Algebra 1 that if we have these 2 terms, this might be something where we have to factor out what they call the greatest common factor. So if we're looking at this 32xy squared minus 50x, we're looking for the numbers that are in common with 32 and 50. I'll give you a moment to think out what's the highest factor of these 2 numbers, 32 and negative 50. So hopefully you're saying 2. So if we factor out 2, also look real quick, are there any variables we can take out? So hopefully we can agree that x is seen in both of these. So if we take out x and start to rewrite how this would look if we factored out 2x, well, 32 divided by 2 gets us 16. Y squared, we didn't use that yet, so let's make sure it ends up here. 50x dividing by 2x is negative 25. And so that's for the first part. So we hold on to that. We've continued to do the same type of song and dance, but now with the right-hand side. So if we look at this, we were trying to find the greatest common factor with negative 48y squared and 75. And a good rule of thumb is that if you really did this correctly, we should end up with the same exact binomial over here. So I'm pretty confident this is going to work. So when you're really, really good at this, you can just jump ahead and say, well, I know that 16y squared minus 25 is going to have to appear over here. But now you have to think out, well, what's the greatest common factor? You could also just think out negative 48y squared dividing by 16y squared, which would definitely be negative 3. So this is just one step. We split these 2. So this was the split. We then took greatest common factors for the first two terms, the last two terms, and now we're going to rewrite this. So we're taking the two greatest common factors, 2x and negative 3, writing that in one binomial, also continuing with 16y squared minus 25 in that second binomial. And we only write this once, so this is just rewriting. So you might think that this is factored as much as possible, but I'll give you a moment to think out. Is there something else here we can factor out? 16 and 25, 2 and 3. Is there anything else we could factor further? Well, hopefully you're recognizing that 16 and 25 are perfect squares, so these numbers come up a ton in algebra problems. These are perfect squares. And it's only now that we kind of see that coming back into full effect, where we have a square subtracting a square. So in disguise, this is really a difference of squares from Algebra 2. If you need any assistance with recognizing those, please let me know. But this we can definitely factor further. If it's a difference of squares, it's as if we have the same type of binomial, but we have different signs for the middle. We'll keep 2x here and the negative 3. But we know that the first two terms have to multiply together and get 16y squared. Well, we know y times y gets us y squared. We also need 4y. We also need the square root of 25, which is 5. So in reality, this is the most factored version of this polynomial seen here. So there was a lot going on here. Grouping's tricky. I'll make sure that there's an additional link with practice online if you need that. But we split this problem up. We looked at the first two terms, took out the greatest common factor. We then continue to rewrite them. Notice, although we see 16y squared minus 25 twice, we only write it one time. Then we also notice that we could factor further. And I'm going to put a question mark here, because this is just a question you should be asking yourself. Can you factor further? Because sometimes you'll get to a difference of squares, and you can definitely do additional work. And of course, you can always check your work. For this problem, dealing with a fraction for our exponent, hopefully we can agree that with 6 and 9, we can factor out 3. Hopefully we can also say that y is a common factor. And you should also continue to get the lowest exponent. So the lowest exponent of these two, which of these is lower, 3/2 or 1/2? So hopefully you're saying 1/2, so let's factor that out. So now if we factor out 3 square root of y, which was the greatest common factor. If we multiply 3 with 2, that gets us back to 6. If we multiply y to the 1/2 power with y, that gets us back to 3/2. If you're not convinced, you can think of this as 2 over 2. 1/2 plus 2/2 gets us 3/2. And 3 times 3 would get us that 9. Luckily, we already have y to the 1/2 power there, so this part's done. And we can't necessarily factor anything further. Depending on who is also working through this problem, you may rewrite this as 3 square root of y, 2y plus 3, just because this is an exponent of 1/2. Probably saw that in Algebra 2, how to rewrite those. So both of these work, but I would personally go for the first one.